All right, this is going to be the end of our waves unit, and we just have a few definitions. And our first one is going to be dispersion. And to disperse, if a bunch of people are in a room and they disperse, it means they spread out. So this is when white light is spread out into a rainbow by refraction. Okay, so we've all seen examples of this before. A common one is when you have a prism and you have white light coming in, which contains all of the colors, and then it refracts when it hits the glass, and it refracts again when it goes from the glass into the air, and out here you get a rainbow of all the colors. Now, why this happens? Okay, each frequency, and remember frequency just has the different colors of light, has a slightly different index of refraction. So each color refracts at a slightly different angle. All right. The next thing is diffusion. And if something is diffuse, that means it is unfocused. So diffusion is the unfocusing of light by scattering from a rough surface. So if I have a mirror, and I have parallel light coming in like this, okay, because the angle of incidence equals the angle of refraction, these are all going to bounce, or reflection, excuse me, these are all going to bounce off at the same angle, and they come out nice and parallel like this. And this is called a regular reflection. All right, and in image will form. All right, now, if instead the surface is rough, and this is just at a microscopic level, all right, and I have light coming in like this, parallel. Since the surface isn't even, it's hitting at all different angles, and when they reflect out, they still reflect out, but they get scattered in all sorts of directions. And that's going to give me a diffuse reflection. And no image forms. Okay, so when I'm looking at this piece of paper, light's reflecting off of it. That's how I can see it. That's why it looks white, because all the light that hits it's reflecting off. But microscopically, its surface is rough like this, and the light gets scattered off in all different directions, which is why I don't see an image. I can't look at myself in a piece of paper like I can look at myself in a mirror. Now, this can also work for transmission when it goes through. All right, so if I have a piece of glass like this, light that comes in parallel, it's going to bend because it refracts, but it's all going to refract at the same angle like that. And we would call this regular transmission. Okay, like when I look through a window, I can see what's on the other side. But if I have, again, a surface that is maybe rougher than that, light comes in like this, still can get through, but it goes every which way, like that. And this is going to be diffuse transmission. Okay, and that's like looking through a window shade. You can still see some light through it, but you can't see images. You can't see what's on the other side. And our last definition is going to be for polarization. And polarization is the direction of vibration for a transverse light wave, or transverse wave, which could be light, but any transverse wave can be polarized. So it has an example up here, all right? We have mixed polarizations on this side. And then there's a vertical filter which only allows vertically polarized light. So all of that light is vibrating up and down. And if we have a horizontal filter, all right, the only light that gets through are the ones that are vibrating side to side. A real life use for this is polarized sunglasses. All right, and in polarized sunglasses, if we look at sunlight, the light coming from the sun has all polarizations. When it reflects off a horizontal surface, it's only going to be horizontally polarized. And we call that glare. Now, if I was to sketch what polarizing sunglasses look like, they would be vertically polarized. Okay, and they only let through vertically polarized light. So they block the glare. All right, so they're kind of special. Regular sunglasses just make everything darker. What polarized sunglasses do is they may be tinted to make things darker, but they're also specifically blocking this glare and letting the rest of the light through. One way you can test and see if sunglasses are polarized, if you hold them and then you turn them 90 degrees, all right, you'll see that when you hold them regularly, okay, they're blocking the glare, but then if you turn them 90 degrees, the glare gets through. So that way you can tell if you're getting a good pair of sunglasses.